Swayam Prabha. Digital India. Educated India.
So today we are going to look at dynamics of love. Each one of us is going to be affected by it at some point or already are affected. But how we are going to react to it depends on each of our personalities, right? Some people are going to, love your partners more if they love you more, and you may get discouraged if they don't love you back. Or some people may get annoyed if their partners love them too much, and they may be attracted to people who are not attracted to them, right? So what you are going to do is try and model the different personalities and understand how the relationship unfolds by building system dynamic models. So that's what we are going to do in today's class. And we are going to capture the personalities by using different parameters within the model and see how it goes. Ready? Let's go for it. Let's start with the classical love story. Boy meets girl, sparks fly, and they both like each other, and his love grows, which makes her love grows for him. She likes him even more, which makes him likes her even more, which keeps growing, probably much to the annoyance of others, but still it grows. Let's call this Romeo and Juliet model. So Romeo and Juliet are madly in love with each other. With each meeting, Romeo's love for Juliet grows because he loves her. He does everything to woo her. Juliet is flattered by his attention, and in return, her love for Romeo also grows because Romeo senses that Juliet loves him. He allows his passion to soar. Right. So now, what will happen to Romeo and Juliet's love? Okay. So now we need to see how we can model this in our as a system dynamic model. But before that, so what do you think is happening here? Each other's love seems to reinforce the other's love on the partner, right? So what we are expecting here is it's a reinforcing loop, which is going to result in a exponential growth in their love for each other. So the question is, if we want to model it, what is going to be the stock? Love is the stock. So let us simply define it as let one lover's love for the other be the stocks, right? Let's have two stocks, one called Romeo's love for Juliet and Juliet's love for Romeo. Let us define two different stocks. Now what will be the units for the stock? Units has to match. We are engineers. We just come up with some love units. Let's say arbitrary, let us call it love units. I don't know how it will be measured. Maybe it is number of what can I say, messages they exchange per day, or number of times they think about each other a day, or yeah, anything like that. So number of likes they put in Facebook on each other or something. Let us say that it measured as some love units, which is somewhat measurable, which we just saw. And let us make some simple assumptions like positive love units represent how much they like each other, and negative love units represent how much they dislike each other, and if it is 0, they are indifferent to each other, right? Okay, so now we are getting somewhere. We have defined two stocks and we have defined the units. Stocks changes through what? flows. So, there has to be 2 stocks, then there has to be 2 flows. It is not a material system, it is not like one love is transferred to other and there is no conservation of flows etc. happening. Each can grow as much as it wants, and we just saw that Romeo's love for Juliet grows based on how much Juliet loves him, and Juliet's love for Romeo grows based on how much Romeo loves her, right. So, they are feeding off each other. We can represent it as a stock flow diagram as shown here. So, let us define 2 stocks, Romeo's love for Juliet and Juliet's love for Romeo, and we have of course any flow that changes it, we just simply call it as changes in Romeo's love, and the changes in Juliet's love affects the stock of Juliet's love. Now you can observe, so this is the basic, I think you can get it. The key thing that we have brought in is something called as 2 parameters, one is Romeo's reaction and second is the Juliet's reaction, right. So here we are trying to capture the personalities where what is the Romeo's reaction to Juliet's love for him and what is Juliet's reaction to Romeo's love for her. In this particular case we just saw that if Juliet loves Romeo, then Romeo's reaction is to gets reinforced, it increases, right. Similar with Juliet's reaction. So, as Romeo's reaction to Juliet's love is positive, Juliet's reaction to Romeo's love is also positive. Okay. So, let us simply capture it by this parameter Juliet's reaction. Let us say each unit of Romeo's love increases Juliet's love by 1 unit, right. So, then we can just set Juliet's reaction is just 1 plus 1, okay. So, now we have a nice looking SD model. The initial love of Romeo for Juliet and initial love of Juliet for Romeo, they are just to denote the initial value of the stocks. It does not change the stock, it just sets the initial value. I just wrote it outside for convenience. So, what we are going to do is see what happens when their initial reactions are different when they meet, right. Okay. So, the Romeo's reaction is similar to Juliet's reaction. So, both is plus 1. So, let us go to the Vensim. So, I just want to show one of the stocks, Romeo's love for Juliet, initial values, initial love of Romeo for Juliet, and changes in Romeo's love is nothing but Juliet's love for Romeo multiplied by Romeo's reaction. So, for each unit of Juliet's love, his Romeo's reaction is going to multiply that by a factor of 1 in this case, and Romeo's reaction is 1 and units is 1 per day, the units of stock is love, and initial love of Romeo is 1, initial love of Juliet is 1. So, what we are assuming is when they meet each other first time, sparks fly and they love each other, love at first sight, both sides. Let us go for it. Let us simulate the model, and what do you expect the behavior to be? I am just going to plot the stocks. You can observe both the stocks increase, it is identical, both the lines overlap, so you do not see the other one, but both are overlapping, and in a matter of 12 days they have accumulated 150,000 love units and it has grown exponentially, right. So, in this, so why does it grow exponentially? Then there has to be a positive feedback, otherwise it cannot grow exponentially. So, let us just trace it. Exponential growth. So, here as Romeo's love for Juliet increases, the change is in the positive direction. So, Juliet's love for Romeo also increases, and because of that Romeo likes Juliet even more. So, it is a reinforcing positive feedback system that we have here, which is causing exponential growth in both their love. Okay. Let us take this case as we just saw. Initially both Romeo and Juliet attracted to each other. So, we just do that by setting the initial value of Romeo's love to +1, and Juliet's love is also +1 units initially. And we have seen this exact same behavior, exponential growth, and we trace the feedback. So, both has to be positive feedback loop, because the reaction is positive. So, whatever amount of love units you are just multiplying it by +1. So, direction of change is still positive. Now, let us do some interesting scenarios and plot changes in the basic storyline. What will happen if initially Romeo loved Juliet twice as much as she loved him? Will Juliet's love ever grow to equal Romeo's love? What do you think? If to simulate it, we can set the initial value of Romeo's love to +2 love units and Juliet's love to +1 love units. And if we simulate it, actually dynamics is as seen here. Both their love for each other is going to grow exponentially, and it is going to still overlap. That is because when we started, Romeo's love was 2 units. That caused Juliet's love to increase twice as much as before, which caused Romeo's love to increase same 1 times more, which again caused Juliet's love to increase. So, whatever setting, they are going to have the same amount of love for each other, but since Romeo loved her twice as much initially, their love grows to 240,000 units, 240,000 love units, much more than 150,000 love units we started with. Let us suppose more changes. Let us suppose Juliet is initially indifferent to Romeo, but Romeo finds her attractive at first sight. That is, Juliet's initial love units is 0, while Romeo feels 1 love unit for Juliet. What do we expect the dynamics to be? It has to increase exponentially. Just think about it. There is initial Romeo loves her. So, with 1 unit, based on that, the change in Juliet's love will also increase to 1. Initially, Romeo's love may not change because Juliet is indifferent to her, but once Juliet sees Romeo's love for him, her love stock, or when she will start reciprocating it, maybe little later. But once both start having positive values, it becomes a positive feedback system which starts reinforcing each other. Let us see how many love units they accumulate in 12 days. Not as much as original, but still 70,000 love units is what they have, because Juliet was initially indifferent to Romeo, but Romeo feels 1 love unit for Juliet, right. Now, still we can experience exponential growth as long as a positive feedback system, and we are going to have non-zero values. System is going to grow exponentially, it cannot grow otherwise. Let us flip it. Those who remember the story will know that Romeo's and Juliet's family fight with each other, they do not like each other. Suppose influenced by their family, they also initially dislike each other. That is, initially both feel -1 love units towards each other. They see each other and they start hating them immediately. Then what kind of dynamics can we expect? People are all drawing in the air, so it is also going to have exponential behavior, but it is going to be accelerated decay or exponential collapse is what we can expect. And just like we anticipated, some of us, their hate for each other will continue to feed off each other. So, with every unit of time, Romeo hates Juliet, so Juliet's hate for Romeo is going to increase, and because that hate increases, Romeo's hate for Juliet will further increase, and that going to get reinforce each other. So, direction of changes continues to be the same, which results in an exponential collapse among them, both going to hate each other forever. How about if it's more complicated things? Although Romeo is initially enchanted by Juliet, she feels a initial dislike for him. I think we simply model it by saying initial value of Romeo's love is +1 love unit and Juliet is -1 love unit. She dislikes him but he likes her. Then what do you think will happen? Will it cancel each other? After some time it will, you have seen too many movies. If we try and simulate it, we actually get a very surprising dynamics. So the red line is Juliet's love for Romeo, green line is Romeo's love for Juliet. This is actually very surprising dynamics because here we have a positive feedback system which is displaying a goal seeking behavior. The entire semester we saw that positive feedback system is exponential growth, negative feedback system results in goal seeking behavior. Now we see that love changes everything. So let us try to understand why that happens, right. So as we just told or just saw, Romeo's reaction is in the positive direction to whatever Juliet's love for him is, right. So let us start there. So Romeo likes Juliet, but he figures out that Juliet doesn't like him. So his stock of love falls, he gets discouraged. But for Juliet, if you see, she finds out that he loves him and her dislike only reduces, and hence we are getting and this happens over time, and you find that they eventually reach point of indifference towards each other, at least as per this model. So that is a very surprising behavior. We just had a positive feedback system just by setting the initial parameters. We never change the model, we are only playing the initial parameters, right. That is quite fun. Just by changing parameter setting, we are getting different dynamics. Some very hyper exponential growths, or exponential growth, the final values keep changing depending on where we are at the initial values. And now with one parameter combination, we are actually getting a goal seeking behavior which is counterintuitive and very interesting. So expanding that, if both Romeo and Juliet are indifferent, that is both feel 0 love units, that means initial stock is 0. So net change is also going to continue to be 0. So they are going to continue to be indifferent to each other, right. They are going to continue to be indifferent to each other. So for this, but this is a very unstable equilibrium. Even if one feels some amount of like to the other person, you are going to start off a reinforcing loop, or a classical love story is going to start, right. Whatever, even if you assume whatever a small number, assume Juliet is indifferent but Romeo feels a very, very slight 1/100th feeling of whatever, of love unit for Juliet, very, very tiny amount, but still if you simulate it, you still get an exponential growth. Of course it saturates at a much smaller love units, but still nevertheless over time they are going to have exponential growth they love. So that is very unstable equilibrium, and even a small change in the positive direction is going to result in a exponential growth in their love, and works the other way also. If you are going to have very slight dislike for the person, that might also get reinforced over time.